Hi everyone, this is Michael Middlemast from the MBC Group. I'm going to go through a very short PVSol tutorial for you today. We're going to do a very basic residential property, put some solar panels on, match an inverter, do a quick string layout, and we're going to do a schematic as well. We're not going to go deep into the financial payback aspects of the software, but we will do some setting up of the project and get you up and running. This tutorial is designed as an add-on or an introduction to our MBC 103 Renewable Energy Design course. If you'd like to sign up for that, please find more detail at mbcrenewables.com. That's mbcrenewables.com, or you can reach out to me. My email address is michael@middlemast.com. So first thing we're going to do in our project file, we're going to set up our user data. So here I will put in my contact details and a little bit about my company, and I would put in the full address of the company, but here I'm just going to put in my website address, and then I'm going to put in my email address. With company logo, I could click load, go through into the computer, find the file, find the logo of the company that I'm working for, and put it in there. So that will show up on the very front of our design when we load the project right at the end when we make the presentation. So offer number, this is the first one I'm doing today. So it's 001. Project designer, that is I, Michael Middlemast. Customer number, we don't have one, so we're going to bring this in from our CRM, our customer relationship management software, or whatever you have in your business. If you have a customer number that's on your CRM, it's very good to put it on your PVSol as well. Just keep that all together so you've got a good reference. Contact person, so this will be the contact person of the customer. Okay, so this isn't a company we're doing with today. This is just a residential client, a person. But if it was a commercial customer, it could be that the customer detail is different to the address of the installation. For instance, I don't know, if you're working with, I don't know, Tesco's, the customer detail might be the Tesco's head office, but the installation address may be a shop they've asked you to work on. So do be aware, customer detail and address of installation can be different. Phone number, I'm just going to put in some random detail here. Fax, if they have one, you can put a fax in, and I'm just going to put in a random customer detail there. So we'll just put in a random fax number as well. Now the address, I do have for us a project that we use on our MBC 103 course. It's called 6 Dale End Close. During the course, we look through this property. I also have a virtual 3D model of the property that we look around, but we're just going to take the address from 6 Dale End Close. 6 Dale End Close, Hinckley, Leicestershire, and the postcode. Always very important to get the postcode. Whenever you're dealing with these projects, it is very important that the client specifically tells you which building it is. Even if you do have the address, it's sometimes very good to get a screenshot of Google Maps and get the building circled to ensure that you're working on the right building. There's nothing worse than spending, hours on a project and then figure out you've done the house next door, or you've done the factory next door, whatever it may be. So once I've got the address in here, I'm just going to click this arrow, which will move the address across. That's great. And I'm going to put a project name. So I'm going to put John Smith Solar Installation. This project image, we can load in an image now, again, from your hard drive, from your computer. However, it will pull through an overhead image of your design once it's done. In the project description, well, we don't know quite what we're going to do yet, so it's hard to put in a project description. But one of the mistakes I see a lot of designers make is they put in the project description solar PV design. Well, That's pretty obvious. We're using PVSol, so we want to try and be more descriptive in these project descriptions. Okay, so we can come back in, and once we've done the design, and then fill this up with it's this panel, it's this inverter system, these optimizers. But one thing I do like to put in is just to start with rooftop solar PV array, and then I'll leave space for what detail that array is going to be, but then I'll put design subject to survey, materials subject to availability. So we want to make sure that we put some caveats in there. The next thing I'm going to do, I'm going to take this postcode right here and I'm going to copy it, and I'm going to move across to this area, and I'm going to change this. Now at the top we can do a grid connected PV system. This won't include any consumption from the client. We can also do a grid connected PV system with electrical appliances, and this will allow us to add in consumption. So we're going to do this one today, but during our MBC 103 course, we cover the battery storage, the electronic vehicle as well, and we cover all four together, and we can look at these other options for you. We really kind of customize the learning to your requirement and what your business is working on. If you're mainly working on residential stuff, we'll focus on that. If you're really working on commercial or even large scale utility scale systems, we can focus in the learning on those for you. But we're going to do a residential grid connected PV system with electrical appliances. I'm going to change the country from Germany to the UK, and it will give us a warning here. Should adjustments be made for the project automatically for the selected country, all financial analysis parameters are reset, all cable settings will be reset, default values for the AC grid tariffs of the selected country will be loaded. It basically means it's going to preload the program with the UK settings or whichever country you pick. So click yes. I'm going to click on the globe now, and it's going to load up the Meteor SIN. A couple of ways I can do this. So I'm going to put in the postcode here. It says search zip code, press start. And I can pick a location that is close to my pinpoint. Or if I click this, create climate data for new location, zip code, search, start, and then click here and make it green. We can see that it's given me now a custom location. OK. And it's going to go back to the database, and it's going to sort this through for us. Now we've got a location for Hinckley, and I'm going to click OK. Very good. So now we've changed, and you can see we've got the longitude, the latitude, the time zone. We've got the time period at which the data was taken. So this is taking an average kilowatt hour per meter squared over a period of 19 years from 2001 to 2020. So we get on average over that time there was 988 kilowatt hours per meter squared per annum. So that's per annum, and we've got the annual average temperature. So this is actually very good conditions for solar PV indeed. We then have the number of phases and the voltage here. So I'm going to change this because this will be a single phase array. So we go into all of these screens in more detail in the training, but I'm just going to change the number of phases to single phase with it being a residential property. That's great. Time step of simulation. Now PVSol will simulate the design. If we select 1 hour, it will give you the output of the solar PV system you've designed for every hour of the year. So 12 a.m. to 1 a.m. January 1st, it will give you, right, this is what the PV will generate, and then every hour through right until December, the end of December. If we click 1 minute, obviously it's going to do the same, but it's going to do it for every minute, which does take a lot more processing power. It'll take more time, but gives you a lot more accuracy. If you're dealing with half-hourly data sets, complex battery storage systems, etc., I really would advise using the 1 minute, but in this case, we're just going to use the hour. The next step for us is to tell the software how much this client uses. There is a couple of ways to do this. We can add in simply the annual value. So if I just type in the average for a UK home, which is 3,500 kilowatt hours per annum, all the software does is it takes that figure and divides it by 12. Well, that's not really a realistic representation of what the user will actually be using throughout the year. It'll vary more in the winter, most likely less in the summer, with it being the UK. So we don't want that. The second best way to do this is if we add in monthly values. So this is perhaps where the client has given you 12 months of bills, and we're going to go through and enter in the usage for every month there. Another way to do it, which we go through in the software, is to add in half hourly values, and you can see all these in green are half hourly values that I've put into my software before. However, PVSol itself also has a wonderful array of customized profile templates. So these are load profile templates. BDEW is the German energy organization, and they've done surveys of different businesses, which is really good. But for us in this case, if I come down to load profiles from day values, there's actually a setting that says UK household, which is really cool, gives us the consumption per hour for a UK household, and then we're going to type in 3,500 for the annual energy requirement and click OK. And then we have a more kind of granular, realistic look at the consumption. Next thing we're going to do, we're going to jump into the 3D design area of PVSol. So I'm going to click Edit. And there's a couple of ways we can import models and create 3D models in PVSol. We can import a 3D model from, say, SketchUp or I believe Blender. There are some basic simple roof areas that it will just automatically put in for us. More complex buildings, walls, open areas. One of the more common ways to do things is really by the map section area. So I'm going to click Map Section, New Map Section, and it's going to load up the area for us. Now you can see it's pulled through the address that we put in the beginning, so it's important that we get this right. And we can see it's centered on the property 6 Day Lane Close. Okay, not a lot of people know or do this, but you can also change the map provider. So this is Google Satellite, but if I change to Bing Satellite, we can see the image changes slightly, so there are different images, and we'll use Bing in this case, and I'm going to click Select. So in the training MBC 103, we go into far more detail here. We can show you how to put in proper drawings, elevations, all of that sort of good stuff. We can pull images from hard drives, scale in the images, and make it really, really accurate from surveys. However, we're just going to deal with the satellite data here. And in the business, we would call this a desktop survey, I guess. So I'm going to click Start. Wonderful. So that's dragged through a scaled image for me. And again, today I just want to do a brief tutorial for you because I do encourage you to join our MBC 103 course. But in very simple terms, we're going to put solar panels on this side of the roof. And I know from my images, if you can see right there, guys, there is two flues in this area that we're also going to put in as shading artifact. So what I'm going to do, I'm going to be in object view, click my pencil, and I'm going to do 4 clicks on the corners of the building. And you can see, because I'm human, obviously this hasn't gone absolutely straight. So I'm going to click off the pencil. You can also right click. And I'm just going to make some slight adjustments just to get this in line with where I want it to be. But to do that properly, I want to right click it, make it a right angle. And then I can drag out the building correctly. Because we're dealing with satellite imagery, this image has been taken obviously from orbit, so the image is slightly skewed due to the curvature of the Earth. Apologies, flat earthers, for mentioning that. But we are going to refine this if we were doing the proper course today, we would refine this using our survey that we got from site. But we're just going to work roughly from the satellite imagery today. So once we've drawn our square, we're going to click our pencil again, and I'm going to draw in the ridge line very precisely, just across. Okay, click off again, right click the building, extrude 3D object, and you can see it's recognized where I've put in the ridge. Average story height in the UK is approximately 2.8 to 2.9 meters. So I'm going to say the height to the eaves, and bear in mind the eaves is this section here, this where where this ends, you can see that's what we call the eave, and where the two roof angles meet, that's called the ridge. So the height of the eaves, I'm going to put 6 because it's 2 stories, and I'm going to approximate the roof pitch at 25 degrees for this purpose. Okay. Now, if I use my mouse wheel, so I'm using my mouse wheel held down to move around in this axis. I'm using my mouse wheel in and out to zoom in and out like this. Okay, and then I hold down my right mouse button and I can move in this direction. So you guys will have to get used to that. If you've ever played any video games in your life, you'd probably be quite good at doing that. So we're going to want to put the solar panels on this south facing roof here. So in object view again, I'm going to right click that roof and then activate, and we can see it now zooms in on the roof itself. One thing I'm going to have to put in now is my edge distances. Under the guidelines here in the UK, I want at least 400 mil around the ridge, the edges. Okay, this is to help stop wind uplift on the solar panels, just make it safe so they stay there and we adhere to all guidelines. So now I've got my edge distances. I can then move to module coverage, select an active module, select active module, new module, and it will bring up my PV modules. And I'm going to select just a popular module here. We'll pick a Trina 400. Just this is a popular module. There we go. Okay, great. I can then choose to have them vertically or horizontally. We're going to leave them vertically in this case, with it being a tiled roof. And there's a couple of ways now I can put the panels in. I can drag them in one by one. Click, drag, okay. I can also use this fill area, click OK, and then I can drag them out like this, okay. And the final way I can do this is if I click cover, and it will cover the roof with solar panels. Now, bear in mind, we saw that this property only has 3,500 kilowatt hours of usage per annum. So I actually think 5.6 kilowatt peak is far too much for this client. So we're going to just reduce that amount of solar to a more sensible. We're going to put 2.8 kilowatt peak right in the center, so it's looking good. And I think this sort of array will produce more than what they need in the summer months and still help them in the winter months too. The next thing we're going to do is match an inverter. So if I go to module configuration, and there are a couple of ways to do this. I can select these panels, right click, select unconfigured modules, and then configure. I could click configure, and I would configure those that I've specifically highlighted. I can click this button here which says configure all unconfigured modules on this mounting surface. And then the next one is configure all unconfigured modules. So if I had multiple surfaces, it would configure them all for me. So we're just going to configure the ones on this roof. And remember, we have 7 modules, okay, and that's giving us 2.8 kilowatt peak. So there are a couple of inverters that we could use, but I'm going to click here, inverter selection. Now, obviously, it would be silly for me to select the 100 kilowatt peak inverters or very large inverters, okay, or indeed 3-phase inverters. We don't need those. So in the database for inverters that you're looking at now, I typed in GINL because I know that's the start of Jinlong Solace. I'm then going to filter these by the AC power rating by clicking this here, okay, and that filters them numerically in descending or ascending order. And I'm going to choose approximately a 3 kilowatt peak inverter because I have 2.8 kilowatt peak. But I also believe the 2.5 could work for us. So I'm going to click the 2.5 here, and I'm also going to click the 3. So now I've got those 2 inverters loaded with a tick. I click select, back to this screen, select configuration, and if I click start, oh, no suitable inverters. That's unusual. Why has it said that? Let's take a look again. Let's pick some other inverters. Jinlong Solis, AC power rating. Let's try again. We'll try this 2.5. Try this 2. And we'll try another 3. Didn't like those inverters I chose. Select configuration, start. There we go. It must have been to do with the voltage of the modules that I chose and the maximum input voltage that's allowed on the inverters that I've chose. And during our MBC 103 course, we actually come away from PVSol, and I teach you a lot about string lengths and how we match inverters correctly for different orientations. It's almost like I picked those inverters on purpose. Could you believe it? So here we do have some options now. Okay, so we've got one string of 7, and you can see the slightly undersized 2.5 is coming out at a better configuration quality for us. So we're going to click OK. And now we have our inverter selected. We're going to click OK. Wonderful. So now we have our inverter selected and our modules in place. You can see it's also given us a string configuration. I could change this string configuration under module configuration, and I could change it to go in a different direction, horizontal, vertical, simple, or meander. But as we only have one row here, it's not going to make too much of a difference. But do know that during the MBC 103 course, we go into depth into stringing. Okay, so we talk about how we can accommodate operations and maintenance activities with proper stringing, all sorts of things. So definitely join us for that. Then we go to cable plan. Now, what will happen now is we need to tell the software, well, where are you going to ingress the cable into the roof and where will the inverter be housed? So to do this, we can click System 1, Cable Automatically, OK. It will place a grommet for us, click OK. And then this is where the inverter will be ingressed into the roof. And what this helps us do is calculate cable losses and cable lengths, which we go into, again, far more detail during our MBC 103 course. So I've put the panels on the roof, I've matched an inverter, I've strung them, everything's fine. I'm going to click Terrain View. Now that looks like a very basic model, so we can very quickly make it look a little fancier. So back to Object View. It zooms me in on the building because I didn't zoom out again. So I right click, back to open area, and then I'm going to right click, change textures. Okay. Now the front surface, I'm going to change it to roof tile, back surface to a roof tile. And this is only talking about the pyramid, the triangle on top of the flat building, these side surfaces, but I'm going to change that to bricks. If I click close and then zoom in, you can see exactly what I mean there. It's only changed these sides to the bricks. So, but that's great. So we now have a nice looking roof. I can then do the same on the side. So right click, change textures, and I'm going to change it to bricks. In our course, we tell you how to put customized textures in, some really advanced stuff we can do. But very basically, again, I can right click on the side, activate, and I can actually drag in, just make it look a little better, some windows, etc. for this property. There we go. Right click, and now you can see the model looks a little better. That method I used there, the clicking and the dragging, is applicable for trees and other objects. Again, we go into that on the full course. So now I would like to finish up. So what I'm going to do, I'm going to take some images of the system, and to do that I'm in Terrain View, and I position my camera using my mouse so I get a nice position. Okay, click on the green there, and then click the camera, shutter release, close, and then I'll come in from a different angle, shutter release, close, Maybe get closer. Shutter release, close. And I always like to get one from overhead as well. Maybe zoom in slightly. Camera, shutter release, close. Wonderful. Once that's done, I would save the project, okay, and then adopt this into PVSol. So what I did there was I clicked the X in the top right, click yes. Should I determine the shading now? I did forget to put those flues in. I do apologize, but as I said in the main training, we'll get you guys up to speed with shading analysis. So we're going to click OK. And there we have it. So now I know what is in my system. I'm going to go back to the project description and I'm going to say 7 times Trina 400 watt modules tied to Solis inverter system. Okay, very good. So we have the consumption in there. We have the 3D design. We can then add in our schematic. So at the minute, our schematic will look very basic like this. And I just want to, yeah, that doesn't look good enough. So what we can add in, we'll add in the feed-in meter. We will add in a add circuit symbol, add in isolator. I don't think we need one after the meter actually. Circuit symbol after the load. Yeah, we don't need that there either. So you can see what I'm doing here is I can add in the different symbols to the system and build up the overall schematic. So we're going to equipotentially bond the system. I think we should add in surge protection. Okay, you can see what we're doing there. Circuit symbols after the inverter, need my AC isolator in there. And we can also add custom symbols in and everything like that. We can put in our bidirectional meter there as well. So we've got our feed-in meter, bidirectional meter, surge protection with grounding, AC isolator, a DC isolator on the string side, a DC isolator integrated into the inverter, and we're grounded along the way. So very good. We could improve upon that. So say if it was a G99, we could put in G99 board. If there was a G100 relay, we could add that in as a custom symbol. Lots we can do here. And again, this is something we go into great depth with on MBC 103, our renewable energy design course. So then we could get a view. And I can change the plant properties here to make it smaller. Okay, we can change the size. That looks a bit better. Okay, and we can actually use that. We can use that on site quite happily. On the financial aspects, this is not something I'm going into today, but I do encourage you again. Sign up for our MBC 103 course. Happy to do some one-on-one time with you, one-on-one time rather, and we can get you up to speed on how to do a full fiscal analysis and get your amortization periods, return on investments, internal rate of return, etc. We can calculate all that for you in PVSol. So straight through to the presentation now. Waiting for it to preview and load, and there we are, guys. We have made a design. Okay, so we can see this system will generate 1015.85 kilowatt hours per kilowatt peak with a performance ratio of 91.97. The client will use 40.3% of the solar they generate, so they will export quite a lot. This is probably due to the usage. So if we increase the consumption from 3,500, they would use less. But this also means they perhaps use some. They're not using much during the day. So I could perhaps go in and then fit a battery, go back into the design and nuance the system. So once you're at this stage, you haven't really finished. Now you can go back in and make amends and really refine the system in line with the client's needs. But we get all of this data here, which we go into great depth on our training course. And if we'd filled in the fiscal data, we could also show the fiscal data. but we have our SLD, our line diagram, our stringing diagram, parts list, and right at the back we've got those pictures that we've taken. So that's it. That's a very, very short and concise tutorial on how to do a very basic residential system design in Valentin Software's PVSol Premium 2024. If you would like to join me, Michael, on one of our renewable energy design training courses, we'd really, really like to see you. The website address is www.mbcrenewables.com. We do one-on-one courses. We can do groups within your team. We can do these online. We can do these at your premises. We have very, very respectable rates, very cost effective. Everyone gets a certificate, and we offer very extensive after-sales support. I'm still working with customers and learners from 3 to 4 years ago, helping them with their PVSol questions. But yeah, I hope you enjoyed this very basic tutorial on PVSol Premium, how to make a residential system, and I hope to see you on one of our courses.